Welcome to ScienceLand. This week, we'll talk about the search for the origin of life. My guest from Harvard University, Furkan Öztürk. Today, we will learn the detail of many fascinating topics, from how the first living creature could have formed 4 billion years ago to the existence of life on Mars. Now, let's listen to the answer to these interesting questions from our guest. How do physicists investigate the origin of life?
Okay, so like origins of life is a really interdisciplinary field, okay? And it's a big problem that requires an interdisciplinary approach from physicists to chemists alike and molecular biologists to geologists, from astronomers to planetary scientists, okay? Because life is a planetary phenomenon and life emerged in this planet through a series of physical and chemical interaction and processes. And we need to be able to collaborate with people from different fields to be able to approach this hard and big problem. So physicists are using their experimental and theoretical skills to investigate the physical and chemical phenomena in the origin of life. And because of the interdisciplinary nature of the field, even physicists do not only do physics in this field, right? Like what they do is they learn a little bit of chemistry, they learn a little bit of geology, and they bring their creative aspects of their physics knowledge to work on problems. Like my problem, origins of homochirality, is requires a lot of physics knowledge, but as well as knowledge from chemistry. So yeah, that's how we do it. We basically bring the expertise of our skills, and then we join that with the expertise of others.
My other questions. What kind of methods do you use in your research?
Yeah, so origins of life is a quest to understand something that has happened in the past, right? In Earth's history, like roughly 4 billion years ago. And most of the record was lost. A true series of tectonic activity, and we don't really have like rock records anymore. We don't really have fossil records anymore. It's kind of like a feedback between different fields, right? Like between, let's say, chemistry and physics in the lab that we do, and like planetary environments and geology in the field. So like, let's say you do a type of synthesis in the lab using various conditions that you think were available, and then you find certain pathways which are better than the others under conditions that, you know, may or may not have existed. And then you go to a geologist, a planetary scientist, and say, hey, look, I made these syntheses, and those are my conditions. And this one is the best one, the most effective one. Can you find me a place on Earth that would have hosted the process? And then the geologist tells you, well, you know, there's this lake in Australia, and it has these conditions, you know, it has a pH range in what you want, it has a mineralogy what you want, it has magnesium and calcium and phosphate. And in addition, it has these salts in there, you know, or these like sediments in there. And then you say, okay, that's interesting. Let me add those salts into my system. And then maybe your synthesis gets even better, maybe it gets worse, but you get a feedback from the field, from the geology, to kind of further refine and kind of make like refine your synthesis, right? And that's needed because origins of life is really a planetary phenomenon, and you can play and make lab tricks and you can make things work in the lab, does not guarantee you that that was the thing that existed on early Earth, right? So that's the important distinction. Like things may work in the lab, however, what we are interested in, what could have worked on early Earth. And for that, we need geology. For that, we need planetary science knowledge. And that's why this is an interdisciplinary field.
Last question. There is talk of life on Mars. What is known about it?
So we could not have found life in Mars, but we think that early Mars, right, the Noachian Mars as they call, is very similar, was very similar to Hadean Earth. So like 4 billion years ago, the conditions of Earth and Mars were similar, not identical, but similar. And Mars did not have a similar history as Earth, and it does not have tectonic activity anymore. It does not have a shield like a magnetic shield, and it kind of froze in time. So because it does not have life on it, which would kind of destroy and eat what was there before, and because there's no tectonic activity, things are not like mixed and intermixed with each other. So kind of it gives us a glimpse into what Earth would have looked like 4 billion years ago. And we can look into its mineralogy, chemical composition, to understand what kind of processes might have happened on Earth. So it's a good lab to study origins of life, planetary history, and moreover, by itself, it's interesting, even if, you know, it would not tell anything anything about Earth, because like we may find traces of life there, you know, we may find conditions that gives us a better idea about what else could have made life. So that's why, you know, we call this field origins of life. It's plural instead of the origin of life, because although we know life on Earth as we know it as a single form of life, there can be other origins. So it's an interesting place to search for it, definitely, because it had conditions conducive to life once. That's important. Like Mars had conditions conducive to life.
Thank you, Furkan. We learned about some new research related to the origin of life today. I hope to talk to you soon about further research on this important topic.
Thank you for hosting me. Great questions.